Types of chemical reactions lab. This is the post lab. So your general setup, your pre-lab, you all looked at direct combination or synthesis, decomposition, single replacement, and double replacement. And the lab does a great breakdown of that, pointing out that the synthesis, I have two becoming one, decomposition, one becomes two or more, single replacement, one is by themselves on one side and now has a partner on the other side, and vice versa. Double replacement reactions, everybody has a partner, and on the other side, they have switched partners. Okay. There's a lot of good information in that. It talks about precipitates, it talks about gases, all of that. So make sure you read through that. And then you did your procedure, you did the copper wire, you heated it up. Hopefully you've got a weight change on that. Hopefully you saw some good changes. Decomposition, you had copper 2 carbonate, you put in the dry test tube, and you took the burning wood and splint to it to see if you could get it to either pop or burn brighter or go out. All right. So hopefully the flame went out because you have carbon dioxide present. And then make sure you weighed before and after. And then you have single replacement where we took 3 molar hydrochloric acid and we took zinc metal and we were trying to fill the top test tube with the gas. And then we brought the flaming splint in and we were listening for a pop because a pop tells us we have hydrogen gas. Double replacement, I have lead nitrate with potassium iodide, and I get this very obvious change because I get this yellow precipitate that forms almost immediately. So the question becomes, well, who is the yellow precipitate? And that's why balancing equations is so important. So hopefully you record your observations and data. And then, oops, that's right, I can't. Here are the reactions written out in balance. I went ahead and wrote out the names as well to get you back to thinking about how you're supposed to do that. Number 5 is what we call a redox reaction, where we have an exchange of electrons. The copper is a +2 on the reactant side, and then has a charge of 0 on the product side. So for redox, we're looking for an exchange of electrons. Leo Ger, lose electrons, oxidation, gain electrons, reduction. So it's a little way of remembering that. Double placement reaction, which was a Ki. Anytime that you have a nitrate, nitrates are always soluble, and I'll show you those rules too. So the yellow stuff that you were seeing was actually the lead iodide. Okay. And then there were some questions that you're supposed to look at in part D, double placement reactions. It states you're supposed to say which one is the precipitate. Like we mentioned earlier, it's the Ki. Explain how you know that. When a precipitate has to be the solid. And then if I have my solubility rules, then I know which one is that substance. Describe what test was used to identify hydrogen gas. Well, hopefully you've done enough time to know we take the wood and splint and we listen for a pop. That pop tells us we have hydrogen gas. Number 3, how does the chemist know the reaction's oxidation reduction reaction? We're looking for a change of electrons. So we're going to have a balanced equation and we got to figure out what's happening before and after. And when we look at that, we see how the electrons have changed. Honors extension, you were supposed to try out the elephant toothpaste, the kids version, and explain the science behind it and write out the equation. This is that equation. Don't forget to do your standard 5 post lab. Solubility rules, and you just need to start learning them. You also have your chart that has it on there as well. Nitrates. So it's just a good rule of thumb. Otherwise, you're checking the list to see Like if I have carbonates, if I have chromates, if I have hydroxides, they're generally insoluble unless they're tied to, notice carbonates and chromates are insoluble unless they're tied to alkali metals or ammonia ions. Hydroxides are going to be insoluble unless they're tied to alkali metals and barium ions. So that's how we know. This is also another one just to use to help you remember this, solubility rules. We have always soluble NAGs and SAGs. So nitrates, acetates, group 1, sulfates, ammonium, and group 17. The exceptions are PMS, which is lead, mercury, and silver, and Castro-Bear, calcium, strontium, barium. So it's a good mnemonic device to remember your solubility rules by. This is a review over your types of reactions, so hopefully you're starting to get this down a little bit. It has not only the definitions, but it also has a image of the general equation. All right. And then you are supposed to know the terminologies. So reactants are what starts the reaction off. They're going to be on the left side. The arrow means yields. And then my right side are my products. The little bitty number, those are called subscripts. The number out front that we use to balance with are called coefficients. And that, like the CO2, H2O, that's our formula. Balancing equations, this is an example one. I generally use 3 rules to get myself through it. I'm going to start with my metals first and get those balanced. Then I'm going to go to nonmetals and polyatomics next. And I'm going to leave hydrogen and oxygen to the very, very end. All right, this is just review over your polyatomics, your metals, your nonmetals. You really got to know your periodic table to help guide you through on how to balance equations. You basically have to make sure that the left side equals the right side. Remember that covalent substances, things that have 2 nonmetals, are going to be using prefixes. Otherwise, you name the first, name the second, because how I name ionics. Okay? Just a review of our old stuff. We've done physical and chemical changes for a while now. We've also talked about endothermic and exothermic reactions. This is just a graph of it to showing you the energy difference between the products and the reactants, which is also why endothermic is cold, exothermic is warm. Okay, and that is it for your post lab. Live long and prosper.